Welcome to solverfy.
So we have a charge distribution that looks like this. We have a spherical shell of inner radius r1 and outer radius r0. We have a charge at the center q and charge inside the spherical shell of magnitude capital Q. We want to find out the field in these three regions: inside, in the shell, and outside. So for part A, the simple thing we need to realize here is that there are two charge distributions: small q, lower q, and capital Q. And the two fields due to these will simply add due to the principle of superposition. Hence, if we find E1 corresponding to the center charge and E2 corresponding to the charge in the shell, we can simply find the net field E1 plus E2. Now, the electric field due to charge lower q will simply be, as we know, 1 by 4 pi epsilon naught q by r squared, where r is the distance at which we are finding the electric field. This will be constant regardless of where we are. We only need to think about the capital Q. Now, we need inside this spherical shell, if you consider a Gaussian surface, you will see that there is no charge enclosed because of the charge distribution in the cell, inside the shell. So the charge due to this capital Q will simply be 0. The field due to capital Q will be 0. Hence, the electric field is simply 1 by 4 pi epsilon naught q by r squared. Now, within the shell, it gets a little complicated. There is obviously E1, which is 1 by 4 pi epsilon naught q by r squared, but there is also field due to charge capital Q. Now, let's say you are at a certain distance r. We can find the charge enclosed within that Gaussian surface. We know that the charge will be simply, because the charge is uniformly distributed, it will be the volume enclosed, which will be 4 by 3 pi r cube minus 4 by 3 pi r1 cube pi the total volume of this shell, which is 4 by 3 pi r0 cube minus 4 by 3 pi r1 cube. So by cancelling off the 4 by 3 pi, we can write it as r cube minus r1 cube by r0 cube minus r1 cube times q, sorry. Yes, so now that we have this, we can write the field again as simply, because it's spherically symmetric, the field will be 1 by 4 pi epsilon naught this new charge. So that's q r cube minus r1 cube by r0 cube minus r1 cube by r squared. That will be at E2. Hence, the total electric field will be q by 4 pi epsilon naught r squared plus q by 4 pi epsilon naught r squared into r cube minus r1 cube by r0 cube minus r1 cube. For part C, once you're outside the shell, all of charge q and all of charge lower q and capital Q are within the shell. Hence, the electric field will simply be charge enclosed divided by 4 pi epsilon naught r squared. So that will be q plus q by 4 pi epsilon naught r squared. That's it.